In this video, we're going to look at page 3 of the Metric System Scientific Notation and Calculations Worksheet. So let's move on to page 3. The first problem is a metallic rectangular solid of mass 1.44 times 10 to the negative 3 kilograms has sides of the following dimensions. Then it gives you the dimensions and says determine the density using appropriate units. Density is mass divided by volume. So the first thing that I'm going to do is write down the formula for density. Well, let's see. Density is equal to mass divided by volume. We also know that volume for this rectangular solid is length times width times height. So we should be able to substitute this right here and place it in right there. So what we end up with is density is equal to mass divided by length times width times height. Now remember that length times width times height, they're all together underneath that line. Now we can do our substitution. Move over here and expand up so we have a little space to work. Density is equal to, so let's put in our mass, 1.44 times 10 to the negative 3 kilograms. I'm going to draw my line here, and I'm going to start putting my mass values or my length values down on the bottom. 4.1 times 10 to the negative 2 meters. I'll put another one down here, 1.0 times 10 to the negative 2 meters. And I'm going to continue on a little bit. We'll say 5.0 times 10 to the negative 3 meters. We can't undo that line. Now let's move back over here and start doing the math. If I take the values 1.44 in the mantissa and divide that by 4.1, and I also divide that by 1.0, and I also divide that by 5.0. Plug that into my calculator and I get this number, 0.0702. Now let's look at those powers. The power on top is 10 to the negative 3. So I'm going to start with negative 3, and then because I'm dividing underneath, this power up here minus 2, this power minus 2, and where did my other power go? We had another line here. We had 5.0 times 10 to the negative 3 meters. This last power, I can subtract these down at the bottom. So we had negative 3 minus a negative 2, minus a negative 2, and minus a negative 3. That's a 3. That's the same as minus 3 plus 2 plus 2 plus 3, which is equal to plus 4. We can put that number in right up here, times 10 to the 4. And our units are kilograms per meter cubed. problem is this isn't in correct scientific notation. I'm going to have to move this decimal point over 2 places to put it right there. And when I do that, I'm going to have to knock off 2 from here. What I end up with is 7.02 times 10 to the 2 kilograms per meter cubed. The meter cubed comes from these meters that are on the bottom. No units cancel. So this is our final answer right here. The next thing that we need to look at are SI units. That's question 36 through 47. And it asks if the units are fundamental or derived. There are only really 4 fundamental units in the SI system. One of those is mass, so this is fundamental. And in the SI system, the fundamental unit is the kilogram. In the metric system, the base unit is the gram. But in SI units, we use the kilogram. A gram is pretty small. So the next one is area. Is area fundamental or derived? Well, area is just length times width, or basically 2 lengths. So that's a derived unit. And we use meters squared or square meters. Length, that is a fundamental unit. That's meters. Volume is derived. Length times width times height. That's 3 different lengths. So that's derived. And the fundamental unit, the SI unit is meters cubed. Speed. Well, the formula for speed is distance divided by time. So it must be derived. And we use meters per second in the SI system. The last one is density, which is mass divided by volume. Mass is fundamental, volume is derived, and obviously when we have an equation, that means it's also derived. And we use kilograms per meter cubed. In the metric system, often you'll see grams per cubic centimeter or grams per milliliter. Those are common metric numbers or metric units, but the SI system, even though it's based on the metric system, uses slightly different, really only for mass. Now let's look down at this last set. Of course, you were assigned to do these, which means I'm going to answer these. You need to know your metric prefixes in order to answer these. 100 meters is the same thing as a hectometer. 1 times 10 to the negative 9 seconds is a nanosecond. And 1 times 10 to the negative 2 meters is a centimeter. You can do the rest on your own there. And we're done with this page.